All right, ladies and gentlemen, so understand what this textbook does. We're working our way through the textbook. We're in chapter 4 now, so we just finished chapter 3. And basically, chapter 1 is all algebra review stuff, things that you guys should be able to do from algebra 2, just basic stuff like solve equations and factor and yada yada. Then in chapter 2, we talked about functions, right? And in chapter 3, we went a little bit farther down that rabbit hole and started investigating the different functions. So in chapter 3, we just finished linear and quadratic functions. And now we're going even farther down the rabbit hole. And now we're doing chapter 4, which is polynomial and rational functions. So that's our goal today, is to get through chapter 4.1. We're going to work on goal number 1 and 2. Okay, the first thing we're going to do is identify polynomial functions in their degree. And then we're going to identify the zeros of a polynomial in its multiplicity. And we'll talk about what multiplicity is and what it does. Okay. Then in 4.2, we'll talk about analyzing and graphing. That's what we'll do tomorrow. So we're going to get through 1 through 10 today, and then talk a little bit about in behavior, and then it'll be time to go. All right, so definition of a poly. By definition, it says a function in this form is f of x equals a sub n x to the n power plus a sub n minus 1 x to the n minus 1 power plus dot 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 a sub 1 x plus a sub 0. And you're like, what in the world? A sub n are just coefficients. They're the numbers in front, okay? N sub n to the n minus 1 power, 1, and so on. Those are just exponents, okay? So we've seen polynomials already. We've seen this guy already. X squared plus 7x plus 10. That's, again, a quadratic. That is an example of a polynomial function, okay? We've seen linear polynomial functions, 7x plus 10. That is an example of a polynomial function. We have seen y equals 7. That is a linear function, which is also classified as a polynomial function, okay? So by definition, our exponent has to be non-negative, okay? Non-negative integer. So it has to be a positive pretty number. So what does that mean? So for our exponents, we can have no fractions, no negatives. It's got to be non-negative. No fractions for exponents, no negative exponents. Okay, so that's our first goal today, is we're going to look at these different functions and identify if it's a poly or not. So when you look at questions 1 through 6, we have to answer yes or no polynomial function. Okay, if it is a polynomial, then we have to talk about its degree. Okay, well, degree is largest exponent. Okay, so if I want to look for the degree, I'm just going to pick out the largest exponent. Okay, so this is going to be a yes or no question, and if you answer yes, then we're going to have to come up with the degree, the largest exponent. So I take a look, I'll do the first one. Okay, the first one I got is f of x equals 6x squared plus 5x plus 1. This is definitely a yes, and the degree is 2. The largest exponent is right there at 2. Okay. So I take a look at the next one. F of x equals x to the negative 1 power and then plus 7. What do you guys say? Thumbs up or thumbs down? Is this a poly or not? Thumbs up or thumbs down? Poly, not a poly? I'm seeing thumbs down. Why not, guys? Shout out. What do you see? Yeah, buddy. We got a negative exponent. So this guy right here is why it's a no. Okay. Now, it's been a while since we talked about exponents. If they're negative, I always say uptown, downtown. If it's x to the negative 1, it's in the numerator. I can send it to the denominator. That's really 1 over x plus 7. Okay. So we really have 1 over x. That is definitely a no. This is actually what we call a rational function. We'll dive into those later, just not today. So I take a look at the next one. I have f of x equals the square root of x plus 3. Okay. Now, it's been a while since we talked about square roots and their powers. If I have a square root, does anybody remember what power that is? So that index is a 2. What's that?
Is it a half?
Yeah, that's a half power. Okay, so I can also write it like this. So if you see a square root, or if you see x plus 3 raised to the 1/2 power, we obviously know that's no fractions. Okay, so this guy, or if you see a square root over the top of an x value, that is a no. Okay, fantastic. So I take a look at the next one. Yes or no? What do you guys think? Joey, Michael, John, what do you guys say? Yes or no? Look at the exponents. 4, 3, 1. Are we okay? Use your microphones, guys.
Yeah.
That is definitely yes. And then degree, what's its exponent? Largest exponent. What do you guys see? Largest exponent is a
4.
A 4. Fantastic. Okay. The next one, I take a look. I got f of x equals x squared minus 5x squared plus 1. Totally fine that coefficient's negative. So this is definitely a yes. And the degree is the largest exponent, which is a 5. So this guy right there. Last but not least, no way. And the reason why it's no is we have a negative 2/3. Okay, for that exponent. That is not going to work. All right, so goal number 1, identifying polys and their degrees. I hope that makes sense. Okay, that was goal number 1. Goal number 2, next we got to identify the zeros of a polynomial and its multiplicity. Okay, now when I talk about zeros, we've talked about this before. When I talk about zeros of a polynomial function, I'm talking about their x-intercepts. So understand that x-intercepts and zeros is the same thing, okay? Now these things are either going to cross the x-axis or touch the x-axis, okay? So it's nice to kind of have a visual here. All right, so here's my x and y axis, all right? And you might have one that starts up here and it goes down and then it comes back up. It touches the x-axis and goes down, okay? So there is 2 x-intercepts on my little fancy graph here, okay? So there's 2 zeros or 2 x-intercepts. This one right here literally goes from one side of the street to the other, literally crosses over. That's a cross. Versus this one goes up, touches the x-axis, and then goes straight back down. So it stays in the same quadrant. Okay, that's a touch. So visually, you need to understand the difference between the two. This is a cross where it goes from one side to the other, from one quadrant to the next. And this one goes, touches the axis, and comes right back down to the same quadrant. Okay, so that's visually what's going on. If the multiplicity is even, so if it's an even multiplicity, then it's going to touch. And if the multiplicity is odd, then it's going to cross. Now, the first thing that you have to understand is what the heck is a multiplicity? Okay, a multiplicity is its exponent. Okay, so for example, if I have a 0, x minus 3 squared, the 0, z for 0, the 0 would be what makes the quantity squared. So x minus 3, if I plug in a positive 3, 3 minus 3 is 0, and that's the 0 or x-intercept. Multiplicity is its exponent. So I have a quantity squared, so I would say multiplicity of 2. Okay? So that's what multiplicity is. It's its exponent. It's this guy right here. All right? Well, if that number is an even number, then it's a touch. And if this number, that exponent, is an odd number, it crosses. Okay, now it's very easy to get those mixed up, so I always try to put things so I can remember and you can remember. And I always remember E.T. Do you guys remember the movie E.T., the little alien? Yeah? E.T. phone home. He sticks his finger out and it glows. E.T. phone home. So I always remember E.T. and then O.C. So E.T.O.C. There used to be a show called the O.C. I never watched it. I think it was in the 2000s. It's probably before your time. But Jay Cutler's girlfriend, that's how she got famous. She was on the OC, or his wife, former wife. I don't know if they're married anymore or what. Good old Jay Cutler. Anyways, I remember ETOC, so ET phone home. The other thing I remember, and let me share you guys with my screen here. The other thing I remember, let's see. And I put this in the right here on the, I got a little video. Okay, put it on Canvas here. Okay, this is my 10-year-old or 9-year-old. Okay, let's see if this is nice and loud. Okay, he's a little goofy, kind of like Mr. Gotch.
Hi, my name is Big Gotch. Isn't this odd?
Oh my gosh, look at that. All right, if that's not odd looking, and then he does like this, I don't know how he does this. I can't do this. Look at that. He's got one eye going in the middle, and then he's got another one going. That's odd, right? So anytime you go cross-eyed like that, and then you can do that, oh my gosh, that is odd. So always remember, odd, when you cross your eyes, that is odd looking. All right, my son is an odd looking guy. All right, so we're back to it. So ETOC, that's how to remember it. All right, so I hope you guys are writing this stuff down. You can have this right on your test. All right, when we're in remote. So when I take a look, it says identify the zeros in their multiplicity and determine whether the graph crosses or touches. All right, so the 5 in front, I got f of x equals 5 times the quantity x minus 3 times x plus 2 quantity squared plus x minus 3/4 quantity cubed. I don't care about the 5 because it doesn't have an x. I care about this x minus 3. So right there is a 0. The 0 is opposite of what you see. If you see x minus 3, the 0 is positive 3 because 3 minus 3 is 0. The multiplicity is its exponent. If I don't see an exponent up there, I just put a little 1. It's like a little 1 in hiding, right? So its multiplicity is 1. Well, that number, that 1, tells me even or odd, touch or cross. So I remember ETOC, that's an odd, that's going to be a cross. So the exponent, the multiplicity, tells me everything. Okay? Questions on the first one? So we do it for every quantity that has an x. So the next one I have is x plus 2 quantity squared. Opposite of what I see, so negative 2 is going to make that a 0, right? Negative 2 plus 2 is 0. The multiplicity is its exponent. Its exponent is a 2. And that exponent tells me even or odd, touch or cross. 2 is an even number. That's a touch. Okay. Let me know if this is not making sense here, y'all. Last but not least, I have x minus 3/4. So if I see minus 3/4, then positive 3/4 is my 0. Its multiplicity is the exponent, which is 3. And that 3 is odd. That's a cross. Okay. So hopefully that makes sense. And again, understand where we're going with this stuff. Eventually, we're going to start graphing this. And when we're graphing x-intercepts, we want to know if that's a touch or a cross so that we can graph it accurately. Okay. All right, let's do the next one together. What do you guys say? Zeros. I got f of x equals x plus 5 cubed times the quantity x minus 2 squared. Okay, so I take a look right here. What's its zero in multiplicity? Tim, Laura, Tommy, Bree, what do you guys got? Shout it out. What's its zero in multiplicity?
-5 multiplicity 3.
And 3 is touching or crossing?
Cross.
That's a cross. Awesome job, Tommy. Okay, fantastic. All right, next one we got this one right here. I've got x minus 2 quantity squared. Braden, Ariel, Emily, Mary, Juan, what do you guys got for this one? Shout it out. X minus 2 quantity squared. What do you guys say?
2 multiplicity 2 touch.
Awesome. 2 is an even number, E-T-O-C, even touch. And that's it. That's all we got to do. Okay, so that's going to be your homework related to those zeros, the multiplicity and even touches, odd crosses. Okay. All right, now, if you can do that, then question 9 is having you go backwards. Okay. So they're asking you to, okay, if they give you the zeros in the multiplicity, if they give you this, then they want you to make an equation like that. So if they say, hey, 3 multiplicity 1, then they want x minus 3 to the first power. If they give you -2 multiplicity 2, well, that's x plus 2 squared. Okay. If they don't say anything about the multiplicity, then you can assume it's a 1. Okay. So we'll do this in different colors. So I've got a function. My zeros are -2, 2, and 3. So let's do -2 first. So that's going to be x minus a -2 is plus 2, so opposite. The next one is 2 for its 0, so that's going to look like an x minus 2. So that when I plug in 2, 2 minus 2 is 0. And then the last one I got is 3. So that's x what? Plus or minus 3? Which one? That's -3. So it's opposite of what you see. So when you plug it in, 3 minus 3 is 0. Okay. The idea is you're taking this -2 and you're plugging it into this x minus r. So x minus a -2 is plus 2. Okay. All right. So first, for me, if we're just doing this in class and I could grade your test like normal and this wasn't Corona time, I would totally accept this. Okay. But it's not. And we're using my math lab, and I try to fix it, but my math lab is very picky, as you guys know. So they want this thing foiled out, okay? Well, this is also going to help us with degree, okay? They will tell you what the degree is, okay? So cover this thing up, foil this thing out, x plus 2 times x minus 2. X times x is x squared. -2x and 2x cancels, and 2 times -2 is -4. And now I'll take that times x minus 3. And x squared times x is x cubed. X squared times -3 is -3x squared. -4 times x is -4x. And -4 times -3 is 12. Okay. Now, as you can see, when I FOIL this thing out, I get x cubed minus 3x squared minus 4x plus 12. That's where the idea of degree comes. They're saying, hey, if you were to FOIL this thing out, to check, make sure you get a degree 3. And we definitely have that. Okay. All right. Questions with that, y'all? Now, there's definitely a relationship between multiplicity and degree. Look at the multiplicities of these guys, right? The exponents of all these. 1, 1, and 1. Well, if the multiplicities are all 1 and the degree is 3, what's the relationship between these? What do you guys think? What's the relationship between multiplicity and degree?
They add together to equal the degree, I guess. The three numbers, yeah.
John, you demand. Yep. Multiplicity is the sum of, well, I guess I have this backwards. Let me reread it. Degree is the sum of multiplicity. Okay. So degree is the sum of multiplicity. So make sure you have that for your notes somewhere. So don't let that freak you out. You can even put a line through it when you first start. Okay. Just go through and set up your zeros and just know that your multiplicities will add up to that number. Okay, John, fantastic. All right, let's try this here. I've got zeros of -1 with a multiplicity of 2, and I have 4 multiplicity of 1 with the degree 3. All right, so let's get it started. So the first one I'll do in blue, -1 multiplicity of 2. So what is that going to look like? What do we got here? Henry, Dylan, Janelle, Braden, what do you guys got? -1 multiplicity of 2. So is it x plus or minus what? Maybe I'm frozen here. Dylan, Henry, Janelle.
It's x plus 1 squared.
Boom. So opposite of what you see, and then its multiplicity is its exponent. Love it. Nice work. Last but not least, I have 4 multiplicity of 1, and I'll do that one. It's just x minus 4. If you want to put the little 1 power, you can. You don't have to. Okay. And then again, John said degree is just your multiplicities added up. Okay. Do we need to FOIL this thing out, or are we good? Do we want to FOIL it out? Yeah, let's do it. This is x plus 1, x plus 1. So I FOIL that out. That's x squared. 1x and 1x is 2x, and 1 times 1 is 1. And now that's times x minus 4. So go through and multiply. I'm going to go ahead and there's 1, 2, 3 terms here and 2. So 3 times 2 is 6. So I got to multiply 6 times. So I'm going to take x times each one of these. I get x cubed plus a 2x squared plus a 1x. And then I'm going to take -4 times all of these. So -4 times x squared is -4x squared. -4 times 2x is -8x. And -4 times 1 is -4. So if I was going to put this into my math lab, my final answer would be x cubed. 2x squared minus 4x squared is a -2x squared. That's a -7x and a -4. So final answer from my math lab. For me, if we're just in class, I would take this, but my math lab is going to say simplify it, which means break it down all the way. Go ahead and FOIL it out. Okay. Questions, y'all? Questions? All right, so we're just about done. I'm going to kind of preview what you're going to see tomorrow before we get out of here. Okay. The last thing I wanted to talk about today was in behavior, and then I'm going to kind of leave it there. Okay. So it says for large values of x's. So I want to think at the ends of the graph. We're trying to figure out what this graph is going to look like. Okay. So for large values of x's, what is our graph going to resemble? And it always resembles the first term. Okay, that's what's called our power function. Okay, our in behavior. So what happens at the ends of the graph? Okay, so for example, if I have y equals x plus 2 quantity squared, right? We could FOIL that out if we wanted to. we would get x squared plus 4x plus 4 if we FOIL. We know what this is a graph of. We know that this is a smiley face. At the ends of the graph, we know they're both going up forever and ever. Okay? Same thing if we had that same thing, we had a negative in front. I had y equals negative x squared plus 4x plus 4. We know what this is a graph of based on the first term. These first terms tell us everything. If I have a negative x squared, we know that it's a frowny face from what we learned in last chapters. Okay? We know it's going down. So the ends of the graph, the end behavior, both sides are going down to negative infinity. Okay, does that make sense? Now, depending on what your exponent is going to decide on what is going on. If it's an even, like x squared, okay, or to the 4th power, okay, it's going to look the same. Or if it was to the 8th power, if that's a x to the 8th, it's going up like a smiley face. If it's a negative x to the 8th, it's going down. So anytime it's an even power, we should know if it looks like a smiley face or frowny face, okay? Versus if I have like y equals x cubed minus 7x plus 10, if this leading term is an odd exponent, then we have to know what x cubed looks like. X cubed goes up to the right and down to the left. Versus if I had y equals a negative x cubed plus 7x plus 10, this negative x cubed is a flip. So instead of going up to the right, it goes down to the right and up to the left. And that holds true for any odd degree. So if the degree of this guy instead of is a cubed is its 5th power, so if that's 5, it's going to follow up to the right, down to the left. If it's negative x to an odd power, it's going to be down to the right, up to the left. Okay, so you really have 4 choices. Okay, so I'm going to change my screen here. Okay, so you can see me a little bit. Okay, so if I was in class, I'd be demonstrating. You're going to have 4 choices based on the degree. It's going to look like this if it's even, or like this. Okay, right? Or if it's odd, it's going to look like this or like this. So you have 4 choices: this, 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 or this. All right, that's it. You have 4 choices. Hopefully that makes sense. So let's apply that to our last examples. And we'll talk more about that tomorrow so you guys get a visual on what's going on. Okay. So if I look at example 7, okay, I have f of x equals 5, x minus 3, x plus 2 squared, x minus 3/4 cubed. I could FOIL that thing out. I don't want to do that. Okay. I know that the degree is the sum, right? My degree is 1 plus 2 plus 3, which is 6. So I know it's going to look like y equals x to the 6th. And then if there's a number in front, it's going to look like that. It's positive. So because it's even and it's positive, it's going up in both directions. Versus when I look at example 8, what's the degree of example 8, guys? What's its multiplicity? 3 and 2? John says add those up. That gives me 5. So this thing is going to look like y equals x to the 5th. So there's no number in front, so it's just going to look like y equals x to the 5th. That's an odd. It's going up to the right, down to the left, like y equals x to the 5th does. Okay, so we're looking for large values of x's. What's going on the ends of my graph? Which direction is it going? Is both sides going up? Both sides going down? Up to the right, down to the left, or down to the right and up to the left? Okay.